Alright guys, I'm going to be out today, so you're watching this video and taking notes just like if I were here. Today we're learning about congruent parts of congruent triangles, so CPCTC. What we're going to use this for, we're going to say if we want to prove parts of a triangle are congruent, that we don't have enough information to prove specifically they're congruent, one way we can prove those parts congruent is by proving the entire triangles are congruent. And then we can state that based on the fact that the triangles, all parts of congruent triangles are congruent, then those parts are as well. So for example, triangle BMA and triangle CMA. If I wanted to prove that angle B and angle C were congruent, I don't have any information to do that. But I've got two sides congruent here. This side is congruent to this side, and this shared side is congruent, and to an angle that's congruent in both triangles. So I can say that triangle BMA is congruent to triangle CMA based on side angle side. And now, because I know all parts of congruent triangles are congruent, now I can state that angle B is congruent to angle C. Same thing here with this these two triangles. So if we know that angle B is congruent to angle D, this segment BA is congruent to segment DA, and these vertical angles here at DAE and BAC are congruent, now we could say that triangle BAC is congruent to triangle DAE, and then we could state that angle C is congruent to angle E. We could state that side EA is congruent to side CA. So if we know that the triangles are congruent, we can state that any part of it's congruent. So sometimes that's what we're going to do. So that's what we're practicing today. So in this example, we're going to go ahead and mark our diagram. We're always marking our diagram. BA is congruent to DA. CA is congruent to EA. And looking to see if there's any other parts that we know are congruent. Well, I know that CAB and EAD are vertical angles, so I can mark those as congruent. Alright, so what I'm proving, though, is not that these triangles are congruent. I can state now, by side, angle, side, that these two triangles are congruent. So triangle BAC and triangle DAE are congruent. But that's not what they asked me to prove. So today, when I write my proof, this congruent statement is going to be my last statement, not that the triangles are congruent. So we're going to go ahead and fill in. So we've marked our diagram. We know that BA is congruent to DA, and we know that because it was given. We know that CA is congruent to EA, and we know that because it was given. Now we know that these two angles, angle CAB and angle EAD, we mark those congruent because they're vertical angles, so that's the reason we're going to give for those. Now, we want to prove that angle C is congruent to angle E. We don't have enough information to do that unless we can state that the triangles are congruent, and then angle C and angle E would be congruent because all parts of congruent triangles are congruent. So that's what we're going to do. We're going to say that triangle CAB is congruent to triangle EAD. And remember that side, angle, side, that's the included angle. But this is not our last statement. That's not what they asked us to prove. They asked us to prove that angle C is congruent to angle E. So that's what we're putting in our last statement. And we can say that angle C is congruent to angle E because now we know that all parts of these two triangles are congruent because we've said that they were congruent by SAS. So now we're going to say congruent parts of congruent triangles are congruent, and you can abbreviate that. All right, we have one more example. So given that AB is congruent to AC and M is the endpoint of BC, we want to prove that angle ABM, so angle ABM, so this angle is congruent to ACM, this angle. So these are the angles we're stating are congruent. All right, so let's go and mark our given stuff. AB is congruent to AC. M is the midpoint of BC. So this is BC. The midpoint means this segment BC is split into two equal lengths. So the length from B to M is the same as the length from C to M. That's by definition of the midpoint. So we're going to say BM is congruent to CM. So they didn't give us that, but they told us that M was the midpoint of BC. So that's how we knew that. And what else do we know? We know that these two triangles share a side. So this side is, so AM is congruent to AM in both triangles. So in triangle AMB and triangle AMC, AM is congruent because they share that side. So, but we still don't have any information about angle B and angle C. But that's okay, because we have enough information to prove that these triangles are congruent, because we have three congruent sides. This side is congruent to this side is congruent to this side, and the shared side is congruent. So once we state that the triangles are congruent, then we'll be able to state that this angle is congruent. So remember, this is the very last statement here. So let's go ahead and put our givens in our proof. BA is congruent to DA, and that's given information. CA is congruent to EA. So CA is congruent to, there is no EA here. Alright, well we are just going to regroup. I'm going to do this on my own. I don't know what that's about, but okay. So we are going to say that AB is congruent to AC, AB is congruent to AC, and that's given. We are going to say that BM is congruent to CM, and that's going to be the definition of the midpoint. I don't know if this is the right thing. Yep, definition of the midpoint. Then we're going to say that MA is congruent to MA, that's a shared side. MA is congruent to MA, and that's the reflexive property. Yep, reflexive property. So now that we can say that these two triangles are congruent because we have three sides are congruent. Each of these represents three sides. So we're going to say the triangle C, no, we're not going to say that. I'm going to write that one in. We're going to say that triangle BMA is congruent to triangle CMA, and that is by side, 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 because all three sides are congruent. Now we know the triangles are congruent. But remember, that's not what we were trying to prove. We were trying to prove that angle ABM is congruent to angle ACM. So now we can say that ABM is congruent to ACM because the triangles are congruent. That means all the parts are congruent. So that means this angle is congruent to this angle is congruent to this angle, but this is the one in our proof, so that's what we're going to put here. So we're going to say angle ABM is congruent to angle ACM, and that's by CPCTC. Congruent parts of congruent triangles are congruent. Alright guys, be good, and hopefully I'll see you on Wednesday.